One sneaky little trick is it can be really helpful just to understand the basics of how do I move between graphs. And so this little table that I've put here is an absolute game changer. If it was my exam, I would write this out as soon as I got to the question paper, because it helps you to remember that the x turning points of an original graph, so here's the x turning point values, are the x-intercepts of the derivative. And so if I want to draw the derivative graph, the x turning points, minus 5 and 1, are the x-intercepts. How do I know where to draw this parabola? This graph is a happy graph because it's going up. So because it's going up, the original graph must have been a positive x cubed or whatever coefficient in front of that. And so if it was positive, then my parabola would end up being positive. And if I followed the same logic and I said, let's do the double derivative or the derivative of this graph, imagine that all you can see is the blue parabola, and I follow this kind of logic again. So the x turning point, so I've got to work it out, and it will be halfway between minus 5 and 1. So that's 6 units apart, so half of that would be 3. So if I go 3 forwards from here, I'm at minus 2, and I don't know how far down, so let me just leave it for now. And let me go back to my table. The x turning point, minus 2, is the x-intercept of my graph. And how do I know what that would look like? It would be a straight line, and because the original graph was happy, the cubic, and my parabola is happy, then my straight line will be happy. And so that's what it will roughly look like. And so sometimes you might come to an exam and the question that you're given is this blue parabola, and you've got to think, how do I get backwards to what the original must have looked like? And so imagine all we see here is the blue parabola. Then you'd go backwards in your logic and say, okay, if I've got the x-intercept, so the minus 5 and the 1 must be the turning points, which at this stage are somewhere. It could be up there, down here. The 1 could be up here, down there. How do I know where it's going to go? Then I see this parabola was happy, and so the original must have been happy. So it must have, as a rough sketch, it must have gone up first, hit that minus 5, down to the 1, and gone up again. And that's extremely, extremely helpful for moving backwards and forwards effortlessly between the different graphs. I hope that you found that video helpful. If you did, please like the video. You are welcome to subscribe to our channel, and please share this with any friends that you might think will benefit from it.